Welcome to Lecture B7. One of the main topics of this lecture will be data representation. And among the ways of representing data are numeric representation, in which you simply numerically list your data values, and graphic representation. And the example of graphic representation that we will consider is the use of histograms. Let's take a look at both of these in a little more detail. An example of numeric representation of data is given here. And we have, if you count them, you'll see that we have 30 data values. And notice that these are not given in numerical order. The idea instead is that these probably represent data that was collected from some experiment, and they are listed in the order in which the measurements were made. And this is the appropriate way to report data. Now, once you want to begin to start analyzing your data, or for instance maybe presenting it graphically, then it is usually useful to sort it. For instance, in this case, we've sorted it in ascending order. But for your initial representation, it is appropriate to report your data in exactly the order in which it was recorded. So here is our data, and this is an example of numeric representation of data because we've just listed it, the numerical values of our data. And then, as we say, when we sort this data, we get this set here. And notice that values such as 77, which were repeated, are written down exactly the number of times that they were repeated. So 77 was measured twice. Right here, the second measurement, and here the, I guess this is the 27th measurement. And so since 77 was measured twice, we list it twice. Likewise here, 91 is listed 3 times, and so on. So we simply, since we're listing every piece of data down here that we had up here, of course, there's again 30 values down here, and some of these are repeated. But now in this list, they're listed in ascending order. And that's about all that we'll have to say about numeric representation of data. Now, as far as graphic representation is concerned, we will concentrate on the use of histogram. And so the histogram shown here actually represents the data that we've just been discussing. So let's try to understand why that is the case. Notice that the vertical axis on the histogram designates the relative frequency, and the relative frequency with which a value is measured, and here on the horizontal axis is the value. Now you'll see that here from 60 to 70 our relative frequency is 0.1. The reason for that is, as we've already said, we have 30 total values, and of those 30, 10%, which is 3, the first 3 values fall between 60 and 70, and so that's why we have 0.1 for the relative frequency here centered about 65. For values between 70 and 80, the relative frequency we see here is 0.2, and that's because 6 values fall in that range. Here's 72, 73, 77, 77, 78, and 79. So 6 values fall between 70 and 80, and that's why we have 20% or 0.2 as the relative frequency for that range. And then this goes on as I think you would expect. For 80 to 90, we have a relative frequency of 0.4. So this is 40% of 30, which would be 12 values in that range. And sure enough, you have 83, 84, 84, 86, 86, 87. So that's 1, 2, 3, 4, 5, 6 values there. And then 1, 2, 3, 4, 5, 6 more values down here between 80 and 90. And then finally, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the 30 values, or 30% of the values, fall between 90 and 100. And so that's why we have a relative frequency here of 0.3 for the range centered about 95. And so that's the example of the use of a histogram to represent data. Now, of course, once you have data, usually you're going to be interested in doing some analysis on it. And one type of analysis that you might do is to calculate the mean. And this is something I feel confident all of you have seen before, but just to make absolutely certain about this, let's look at one example. Let's say that we have the following data. We'll say maybe 10, 12, 13, 17, 20. Then the mean, which is frequently denoted as X bar, will be equal to 1/5. That is 1 divided by the total number of data points that you have. Altogether, we have 12 pieces of data here, so we have 5 pieces of data: 10, 12, 13, 17, and 20. And so that's why we have a 5 in the denominator here. And in the numerator, we just have the sum of those data values. So 10 plus 12 plus 13 plus 17 plus 20. And so I guess this will be 12 and 13 is 25, 35, and 37. So I guess that's 72 divided by 5. And so we have 14.4 is the mean of this set of data. Now we can also calculate the median. And to calculate the median of a set of data, what we do is list the data in order, and that's already done for us here. We have this in ascending order, and then if the number of pieces of data you have is odd, then the median will be simply the number in the middle. So in this case, the median would be 13. Now, if we had a even number of data values here, so for instance, let's say that we had maybe 6 data values rather than 5. Well, then there wouldn't be one in the middle. There would be 2 in the middle. And so in that case, we would take those 2 middle values and take the mean of those 2, and that would be the median. So for instance, just to make sure that point is clear, let's say that the median of let's say, just to keep this easy, 10, 12, 13, 17, 20, 21. Okay, this is 6 values, and so to calculate the median of that, we take these two middle values and take their mean. The mean of those two is 13 plus 17 divided by 2, or 30 over 2 is 15. So the median of that set is 15. That's how we calculate the median for a set of data that has an even number of data in it. And then we also, returning now to this example here, we can also calculate something called the variance and the standard deviation. Now the variance is given the symbol s squared, and it is equal to 1 over n minus 1, where now n is the number of data values that you have. So here we have 5 data values, and so 1 over n minus 1 would be 1 over 4. And then we add up the squares. Well, let me just show you. We'll have 10, that's our first data value, 10, minus 14.4 squared, plus 12 minus 14.4 squared, plus 13 minus 14.4 squared, plus 17 minus 14.4 squared, plus 20 minus 14.4 squared. So we take each data value that we have, 10, 12, 13, 17, and 20. We take each one of those, and each time we're going to subtract from that value the mean value that we calculated, and then we're going to square the result. We'll add all those squares together and divide by 1 over n minus 1, where n is the total number of data values we have. And so, in this case, let's see what this will give us. Okay, if you, unless I've made an error, I believe that you will find that s squared, when we square up all of these terms in the brackets, we get 65.2, and then we have this 1/4 out front, and so we have 65.2 divided by 4, which is equal to 16.3. So the variance, which again is denoted as s squared, is equal to 16.3, and the standard deviation, which is denoted as s, and is the square root of s squared, will be 4. To 4 decimal places, it'll be 4.0373. So that's how we calculate the median, the mean, the median, the variance, and the standard deviation of a data set. So now let's look at some problems on these concepts. Okay, for the problems for lecture B7, for the first problem, I want you to consider this set of data. You will see that there are 20 pieces of data in this set, and I ask you which is the correct histogram for this data. So here is A, here is B, and here is C, and here is D. So you just need to look at that set of data and decide which of these 4 histograms is the correct one. Now we have for problem B7-2 a different data set. We have this data set 10, 3, 12, 17, and 8. And I ask what is the median. The choice A is 10, choice B is 3, choice C is 12, and choice D is 17. And then problems B7-3 and B7-4 will be given in class. And so that's it for lecture B7, and good luck.